A ball has elasticity such that on each bounce it bounces to 80% of its previous height. Find the total vertical distance travelled by this ball when it is dropped from a height of 3 meters and allowed to keep bouncing and bouncing and bouncing until it comes to rest. So we need to ignore friction and air resistance, which is fortunate because I don't know how to deal with those. So let's think about this ball. So say we've got the floor and we've got the ball and it's dropped from a height of 3 meters. So once we drop the thing, what it's going to do, firstly it's going to fall 3 meters and then it's going to bounce back up. So it's going to bounce to 80% of that. So we're going to definitely need 80% of 3. So I could just do this with a cat, so 3 times 0.8. But, well, 10% of 3 is 0.3. So 20% of 3 must be 0.6. So 80% must be the 100%, take away the 20%, which would be 3 take away 0.6, which must be 2.4. So it's then going to bounce to 2.4 meters. Don't worry, I'm not going to keep doing this. I'm just trying to make a point. So then it's going to fall a whole 2.4 meters, and then it's going to bounce up again to 80% of 2.4 meters, and then it's going to fall that, and so on. What I'm trying to get across is it only travels this 3 meters once because it's dropped from that height. So it travels the 3 meters, and then every other height, because this thing's just going to keep bouncing and bouncing and bouncing, less and less each time until it stops. So every other height that it bounces to, it needs to fall that same height again. So in terms of finding the total distance travelled, so total vertical distance, apart from that 3, which it only does that once, everything else it's going to travel that distance twice. So we need to work out a formula that we can use for this. So firstly, this series. So I'm going to take the 3 as being on its own, and then I'm going to look at what happens. So then you've got kind of 2.4, then you've got 2.4 times 0.8, then you've got the answer to that times 0.8. So that is a geometric series because every time to get the next term, we multiply by 2.8. So this is a geometric series with u1 equals, I'm going to say u1 is 2.4 for reasons I've just mentioned. So I'm going to treat the 3 separately, and everything else I'm going to have to double, so I'm going to put them all together. So u1 equals 2.4 and r equals 0.8, as in the multiplier that finds 80% of the previous value. So the total, I need to find the total distance travelled. So total distance, so it's the first drop equals 3 plus 2 times the sum to infinity of the rest. Because this is an infinite geometric series, as we allow the ball to stop to bounce until it stops bouncing, until it comes to rest. If you could sort of really zoom in on it, you'll see tiny little bounces that's kind of bouncing, and you can't even see it, but they do make a tiny difference to the sum. So it's 2 times the sum to infinity, as I said, because every time it bounces up, it needs to go down again the same distance, then it goes up a different height, then it goes down again, then it goes up and it goes down again. So we need to work out this sum to infinity, which is u1 over 1 minus r. Okay, which is a very useful formula to remember. It's not actually in the new IB formula book, but it's you can get it very quickly from the partial sum if you know that for large n, once your r is, the absolute value of r is less than 1, you know that the 1 minus r to the n term goes towards 1, or r to the n minus 1 if you use that one. So equals 3 plus 2 times, or u1 I've said is 2.4 because that's the bit I'm considering for the geometric series. u1 2.4 over 1 minus r, so 1 minus 0.8. Okay, so 2.4 over 1 minus 0.8 is 12, so it is 3 plus 2 times 12. I've just used a calculator for that. 2 12s are 24. 3 plus 24, so the total distance traveled must be 27 meters. So vertical, that includes the 3 meters initial drop, and then every bounce up and down, and that's what this 2 is, so the up and down. Okay, and that's the final answer.